Okay, so we've got a service call on a prep table not working. This is what I see when I come up here. Got a nice chunk of ice, and the first thing I do, we have a history of water damage with these guys, so I open up this control. You can see that calcium right there. And you can also see the calcium around the lip where it goes. I can pretty much guarantee we're going to have a water damaged temperature controller. But we're not going to just focus on that. We're going to go ahead and defrost it and do a full diagnosis on the unit and confirm that it's a bad control. So there's a bunch of screws that hold this on, but the only tricky one is this one right here, and it's hard to get in there. I use a 5/16 ratchet wrench, bust it off, and then everything else is pretty straightforward. So to defrost this, I'm using a pump sprayer like that with hot water. And I'm just, starting at the top of the coil, blowing down. Make sure I get it nice and thorough. And it was overflowing the drain pan, so I added a piece of hose. That way it's draining into a pan now, and I can dump it in the mop sink instead of making a mess everywhere. Okay, I'm going to, I got it all defrosted, but before I put the cover back on, I'm going to do a quick leak check just because I saw that funky ice pattern. In order to do that, I got to turn the unit on, and I've got to get the top section running, because I had it off, and then I gotta wait for it to kick on, and then once it kicks on, I had it off at the control, so that means it pumped down and there was no pressure on the low side. So once the control kicks on, then I will turn it off at the switch, so that way the pressures are on both sides and I can do a quick leak check. But again, I'm not gonna waste a bunch of time because I haven't even put my gauges on this yet. I'm just doing this before I put the cover on. Okay, so I did a quick leak check, didn't pick anything up, put the evaporator back together, tested the refrigerant pressures. Refrigerant pressures looked good. So now I'm going to go ahead and change the temperature controller because it is acting like a bad control. So this is the back side of the box. The probes run all the way up to the front where the temp control is located. They run through here and then into the box. And they're kind of difficult because they go through a bunch of different places to get them changed. So here's what I do. I take the old probes and you leave them in there, and you tape the new ones to them, and then you carefully pull them through, and it makes a bunch of turns, and it's nice and smooth, and then you don't have to pull the coil off the wall. If you cut them and mess up or something like that, then it's not a huge deal, but you got to kind of pull the coil off the wall and then finagle them in there. So also this gets a cover, which is right there. So almost done. So this is the other side. This is the air probe. Also pay attention to where they go. The blue one goes in the coil, the black one goes in the air. So I've already pulled the blue one through. You just pull it nice and slow. Don't yank on it. If you feel resistance, you need to figure something out because you'll pull the tape off. It's starting to get a little resistance, so just get back here and carefully pull it through nice and slow. And there we go. We just pulled it through. So that hole is actually on the bottom down here. So it's got to come through the hole with a little washer up and then in through there. So that's why it's difficult. So if you mess up and you don't tape them, you could pull these two screws and these screws, and you can bend the coil out of the way and fish them through with your hands too. But this way is just a little bit easier. So I got that cover put back on. The wires are ran through properly. They go through a little channel. They come out right here. This is the sensor wires, and then we're going to zip tie them up to this little chingus right here, and we'll get them plugged in. But I'll get them plugged in first. Okay, got everything secured. Ran up there, and I'll show you guys something on the front too. Up here in the front on the sensors, you want to tie a big knot, because one of the things that can happen is people can yank the sensors right out of the temperature controller. So by tying a knot, it's going to get stuck on that little grommet and it won't let you pull the wires out. That's just a little tip. Okay, doors are back on, unit's running. You want to keep in mind that the temperature controller has like a 3 or 4 minute delay on it. So when you turn it on, you got to give it a few minutes. So we're going to let it run. We're going to monitor the cut in and cut out temperatures to make sure it's turning on and off where it should be. And then hopefully we'll be done with this box. Time clock. Looks like it has the right time on it. So there it goes. Temp control just kicked in. So I'm going to monitor the pressures. Okay, so controller's ranging. Turning on at about 38.
Should be a little closer to 39, but it's turning on under 40, so that's what matters. And everything's looking good. Refrigerant pressures look good, so we're good to go.
So that was a service call on a Delfield prep table. The bottom section wasn't working. It had a bad temperature controller. It was bad because of water damage. This is a very constant problem we have with this particular customer at all of their restaurants. They're constantly ruining temperature controllers because of water damage. They're trying to clean their floors. They splash buckets of water to try to clean the boxes, and just the way that they're designed causes the controls to get wet and they go bad. Trust me, I've brought up to them my ideas about solving this problem, and it kind of goes to deaf ears. Nobody really wants to listen to me, so I stopped trying. Okay, I know of tons of ways to fix this and eliminate this and stop it from ever happening again, but I've brought it up to the customer, I've brought it up to the manufacturer, and nobody seemed to bite on my ideas, so I just let it go and stopped, bringing it up to them. This particular box has a cold rail on the top section, a refrigerated evaporator section down below that has a normal fan motor. Okay, the cold rail is a static pan chiller, so there's no evaporator fan motor. The cold rail is controlled by pressure control. Okay, that pressure control doubles as a low pressure safety switch for the entire unit also. Okay, so think about that for a minute. The top section will now run whenever the bottom section is running because there is no temperature controller for the top section. It uses the low pressure safety switch. It's just set a little bit higher than normal. I should say a little bit higher than a normal pump down circuit. So it's set to maintain about 17 degrees in the pan chiller section. So anytime the bottom section calls for cooling, the top section is going to run too. So in the wintertime, we actually have nuisance service calls because they tell me that it's getting too cold in the top section. What happens is they're usually pretty busy, but it's not very hot in that kitchen. So they're opening and closing the bottom doors a lot, and they get problems with the top section getting too cold. Okay, so it's just an interesting design flaw inside the box. Anyways, the unit's working correctly. Everything was good. Really appreciate you guys watching my videos. Give me a thumbs up. Consider subscribing to my channel. Leave me a comment, and we'll see you guys on the next one.